So in this video, we're going to graph the absolute value parent function. So up here at the very top, what you'll see is the parent graph for the absolute value function. And this is called the parent graph because it is essentially the simplest of all of the absolute value graphs. And we can actually transform this parent graph to find every other type of absolute value function that we could possibly graph. So we're going to get this graph down so that we can transform it and turn it into other variations of the absolute value function. Now notice, to be the absolute value function, hopefully it's fairly obvious, the absolute value function contains the absolute value symbols, and we can see those right here. Now hopefully you also remember that the absolute value symbols, the number that goes inside of them, essentially what we are finding is we are finding that number's distance from 0. That is what the absolute value function does. Now what we're going to do here is we're just going to graph this function by finding a table of values, and I suggest using x values that hover right around the y-axis, which typically include -2, -1, 0, 1, and 2. And what we're going to do here is we're just going to substitute in values for x into this equation and find the corresponding y value. So here off to the side, we have y is equal to the absolute value of -2. Now remember, absolute value finds distance from 0. -2's distance from 0 is 2. So my first point there is x is -2, y is 2. I can go to my graph and plot it, -2, 2. Then I look at my next point and I see, okay, I have y is equal to x is -1, so we're finding the absolute value of -1. Well, -1's distance from 0 is 1. So I have x is -1, y is 1. Then I go to the next value. Y is equal to the absolute value of 0. Well, the zero's distance from 0 is just 0. So here I have the point 0, 0. Then I look at the next one, and x is 1, so y equals the absolute value of 1, which is simply 1. So we go to the point x is 1, y is 1. And then the last one here, we have y equals the absolute value of x, which is 2. 2's distance from 0 is 2, so our last point is x is 2, y is 2. Now what you should be seeing here is that our graph actually starts to look like a V, and that is the general shape of an absolute value function. So if you see something with an absolute value in it, it will have this general shape. All absolute value graphs have a V shape. So that's what you should expect to see. So all of the graphs that we're graphing that contain absolute values will look something like this parent graph, but it'll be a transformed version of it. Now, the last thing we need to do here is we need to find our domain and we need to find our range. Now remember, domain are all of the x values that we need to make points on this graph. And what I notice when I look up here at the absolute value function is I notice that this graph is going forever to the right and forever to the left. And I know that when I'm using all of the numbers to the right and to the left, that my domain is all real numbers. Then if I pause for a second and look at my range, remember your range are all of the y values that you're using to make points on your graph. So range are our y values. What I notice here is y values I don't need consist of all of these negative numbers. I don't need any of these down here. My graph doesn't come down here at all. So I don't need any of those y values down there. What I need instead are the y values that start at 0 and go up, because I need when y is 1 to make these 2 points, when y is 2 to make these 2 points, when y is 3 to make these 2 points, so on and so forth. So what I'm noticing about my range is that my range starts at 0 and goes up. So I'm going to reflect that by saying y is greater than or equal to 0. But here is our basic parent absolute value function, and what we're now going to do is we're actually going to start transforming this, moving it around, stretching it and shrinking it, seeing what changes we can make to this basic absolute value parent graph.